what's c minus c always going to be? A 0. So you don't have to put if it's a definite integral. So I just want to give you a quick example. On this problem, you don't have to put the plus c, but if I ask this, you can put this in your notes. I want to give you time to do this. If I asked you for that this question right here, evaluate. Now this is called an indefinite integral. Okay. Evaluate the indefinite integral. Oh. Josephine, I don't see anything here, right? So we're just going to have to put down the antiderivative. What's the antiderivative positive sign? And now I put the plus what?
C.
C. This is called a what? What kind of integral? A definite integral. So evaluate the definite integral. Aha! Definite values that we can actually find the area and accumulate the area. If the function goes underneath the x-axis, we're going to subtract that out area, correct? Does that make sense? So indefinite integrals, there's no limits here. We're just putting down the what? The antiderivative. Is that clear? So hey, when are we going to put plus c every time with these integral symbols? If there's no what here? There's no numbers. You don't see any numbers here.
Does that count if it's a variable as well? Like if it was a and b?
If it's a variable and a number, then we don't have to put the plus c down.
The only time you put the plus c down is if there's no.
Just
numbers.
blank. Just blank.
Okay.
And you know what's even better, Josephine? What if you put down plus c 100% of the time? You still would be fine because what would happen anyway? The two c's would just what?
Cancel out.
Cancel out. Cool. Hey, so I'm going to do this. I don't have to put plus c. What number do I have to put in there?
2 pi.
2 pi.
Mm-hmm.
But be careful, everyone. Is it a plus or a minus? Look. What's this say? I got to do a what? A minus. It like accumulates area and then it subtracts out the accumulation of the next area. So I have to do a minus, then you have to put a negative, and then a cosine of what?
0.
So far so good? Yeah? What's a minus times a minus?
Plus.
Negative times a negative is a plus. Alright. Now we all expect this answer should be 0, right? Who knows a cosine of 2 pi?
1.
That's a 1. Who knows a cosine of 0?
1.
What's negative 1 plus 1?
0.
Now, how do we check on this again? How do we check on this again? It's fun. Can you do it? It's kind of fun. You know, hey, I could have made an error there, right? Can't check indefinite integrals, but I can check what? Any definite integral. So let's do it. I go to y equals, right?
Mm-hmm.
What function do I have to type in here?
Sin x.
Sin x, put the original. So you might be like, everyone, I recommend being in radio mode. So I recommend being in radio mode with this. So we can put it in radio mode. Alright, go to y equals, put the sign of x. I'll let you see this. Now, I hit graph, right? And the thing goes squiggling all over the place. Zoom 6 does a standard window. We're going to go second trace, right?
Mm-hmm.
Everyone go to second trace. And which one is it?
6, right?
Number 7, correct?
Number 7.
Number 7, it says lower limit, what do I punch? 0, hit enter. That says upper limit, what do I hit? Hit 2 and then hit pi, and then hit enter, and my got this as 0. But I want to make sure yours does the same, does it? Unless, let me know, Art, if it does one of those 1e negative
No,
2's
0.
or something. Does it work? Let's get the area from 0 to pi, what's going to happen? Pause it, boom. This is everyone, don't think like, wow, this is going to help me cheat on it. No, it's a learning tool. It helps you see it and you go, yeah, that's 0. Is it working? I'm going to come to both of you real quick. Let me see it. I love it. Look at that. You got it. Integral 0, just like we thought. Right? I'm going to go to yours. Did it work? Did it work? He's got it. Let's see what happened. I'll go to 1. I'm going to look at this. That looks good. I'm going to go to your mode. You're in radian. I like it. and I'm gonna go graph. It probably didn't go far enough, so I'm at zoom 6. Zoom 6 gives a standard window. That's probably why it went outside the window. That's far enough. So now we can go, it probably didn't go far enough. The 2 pi was too far out. I bet you that's what the problem was. And then we try it, now it's gonna work. All right, here we go, number 7, right? 0, and then 2 pi. Ta-da! Isn't that cool? Hey, can we do another? This time, everyone. I want that. So what changes now? What changes in this image?
0 to pi.
Who could predict the answer? I always want you to think graphically. Is this answer positive or negative?
Positive.
See how smart, oh, you're awesome. You're like, I know this answer is positive. Because you have knowledge of the function. Now, if it's some bizarre function after that integral symbol, yeah, we might not have knowledge, but, we know x squared, we know x cubed, we know these common functions, sine of x, cosine of x, right? Let's try it. So negative cos, 0 and what?
Pi.
Negative cos of pi. Don't forget subtraction. Negative cos of 0. Hey, what's cos of pi?
-1.
All right, what's a negative negative 1?
+1.
Is that 1?
Mm-hmm.
Yeah.
So if you're doing it on your calculator, you shouldn't put the negative sign and then the cos. You should just take the cos and then add the negative sign to it.
That'll work.
Okay.
Hey, what's a negative times a negative?
Positive. Cos 0 is
So
1.
what's a 1 plus a 1?
2.
Isn't that cool? What's the area of that region right there? A perfect what? It's not an irrational number. The area is what?
2.
Exactly 2. I think that's cool. Do you? I think that's cool when you got this function sine of x, but the area inside that region right there is perfectly 2. Perfect 2. Isn't that cool? Man, you're good. I think you got these trig functions down. Can I erase this image? All right. Hey, is this called a definite integral or an indefinite integral? Definite integral. So we should get a definite value, right? Hey, what would you do if this was the question? How would you leave the answer?
We have to add
Make
a
sure you're
C.
going that way, right? Make sure you're going that way. What would it be?
Sine.
Sine of x, and then what would I have to write?
Plus C.
Right? I need you to do this. Now, I'm looking around at the faces. I'm trying to read your minds. I was wondering which student was doing this graph in their head so they could predict the answer. Who knows about the Art's doing it? Anybody else? What's the cosine curve do? What's it kind of look like?
1.
I'm not saying you have to do it every time, but boy does it help sometimes. You're like, wait, this graph starts here, gets to there at pi over 2, and then it gets where? What do you all think the answer to this guy's gonna be?
0.
All right, let's see. All right, sine of x. Da-da-da. I don't have to put the plus c. Put my pi. Put my 0. Everyone's sine of pi is 0. Sine of 0 is 0. Just like we thought. What we're getting? 0. Cool. Yeah. All right. Don't let the next one stump you. Don't let the next one stump you. We better put some notes over here. This could make someone go crazy on a test or a final. They'd be trying all these like, what do I gotta do? Quotient rule, product rule, whatever. Let me just go over here, a little reminder. We got the s and the c's. And what was the derivative of tangent?
Sine over cosine.
I mean the derivative
Oh.
with respect to x? Secant squared, right?
Mm-hmm.
Okay. Don't forget about that. And who's the other popular one? What's the derivative of secant?
Secant x tan x.
All right. Because I'm telling you, don't ever let these escape your mind. I know the cotangent and the cosecant don't come up as often, but boy, you might stare at this is the problem where you go, man, I would have finished that test an hour ago, but this problem stumped me.
How do you do a secant of something on the calculator?
1 over cosine. 1 over cosine. Zero to pi over 3.
Alright. Hey, Ellen, this is actually, would you do me a favor? Would you make that power 6? You know why? I'm gonna write this. And when you're gonna give me the exact value, keep in mind that calculator doesn't give exact values, does it?
No.
Right? Well, hey, I need a little triangle here. We all know this triangle from the trig sheet. 1, 2, and what? Square root of 3, right?
Yeah, root 3 over
And
2.
there's 60 degrees, and there's
30.
30 degrees. But the most important part to this problem, and when I'm being honest, you could stare at this for like 30 minutes. And you'll be sitting there going, what do I have to do, product rule? Is there a product rule for integrals? And you're freaking out when all along you're like, hold up. What's the integral of secant tan? Secant, you follow me? Same thing happens with secant squared. You look there, you look at integral of secant squared, you're like, what's the integral of secant squared? It's tangent x, right? Alright, so this is just now becoming what? Secant of x. I don't have to put the plus c. Now what number's not to substitute?
5 or 6.
And it's not as bad as you think. Secant's reciprocal, buddy, is cosine.
Mhm.
And when the cosine of 0 is 1. So let's start with the easy one. What's 1 over 1?
1.
Easy. Let me do it again. Secant's reciprocal, buddy, is cosine. Cosine of 0 is 1. So 1 over 1 will just be what? 1. To do this, so katoa, cosine of power 6, check it out, is adjacent over hypotenuse. So when I gotta do the reciprocal of that, what's the reciprocal of square root of 3 over 2?
2 over 3.
That's exact.
Wait, go back over that.
Oh, I'll do it again. It's just, hey, Josie, it's only that little triangle. As long as I know that triangle right there from that trig sheet, and now cosine, remember, cosine is SOHCAHTOA. SOHCAHTOA. Cosine is, here's the angle. There's the angle. I got to do adjacent over hypotenuse. See, adjacent over hypotenuse.
What are the angles in there?
That's a power 6, that's a power 3. And I just have to do the reciprocal then. And the reciprocal becomes 2 over square root of 3. So it's just the trigonometry. Now everyone, that's fine for a test. You don't have to rationalize the denominator for me. But who would like to rationalize the denominator if you wanted to? I'll bet you the back of the book would. 2 square root of 3 over what?
So 3, sorry, square root of 3 over 2 divided by 3.
That would be 2 times the square root of 3 over 3 minus 1. But everyone, I can't write this more exact. So if you had a high-powered calculator in here, that's how I'd write it. Or it would write it as 2 square root of 3 minus 3 over 1. So I'm going to write that. Some students, they've been schooled all along, always rationalize denominators, so they might write it like that. You know? Like my teachers. Always got to rationalize the denominator, right? Good deal. Any questions on that one? All right, let's try another one. Ready? How about enough with the trig functions? 6x cubed plus 2x. Let's go from 1 to 4. Cool. What's this become?
X to the power 4.
Can you find my error? And when it happens on tests, be careful.
Yeah.
You know, you leave the room, you get in your car and you're driving away and you're like, Oh my gosh, did I take a derivative by accident? What's wrong with that?
That's the,
Whoops, I went derivative of this, I need antiderivative, what is it?
4 divided by 4.
You make reduce to 6/4 to what?
Yeah, 3 halves.
How about 2x?
X squared.
Do I have to put the plus c's?
No.
No.
Good. Now what am I substituting first?
4.
Substituting 4, right?
Mm-hmm.
Then I'm gonna substitute a 1. And what am I gonna do with these? Subtract.
Professor, why don't you make the 3 halves?
I'm gonna do that. I'm gonna make this 3 halves. I agree. Art, I agree with you. You say, hey, make that neater before we substitute these. All right, put in 4 in there. What do you get?
3 over 2 times 40 over 4 plus 4.
I'm gonna do this. Look. I gotta get that number right there. Then I have to subtract, and then what am I putting in there? What am I substituting?
1.
Yeah, but I want that's 4 to the 4th. 4 cubed is 64 times another 4 is what? 256.
Yeah, 256.
Now
Yeah.
what's 256 divide 2?
128.
A lot of you will use your calculator to support you here. 128. Now what's 128 times 3?
So that's 300. So about 28 times 3 is how much? 72. 128 times 3. 384. Sorry.
384.
Mm-hmm.
Now what's this number right there?
16.
Now what's, oh, we get a fraction. What's 3 halves times 1 to the 4th?
3 half plus 1.
So what I'm doing, there we go. I bet you a lot of you would check this during your test, wouldn't you, with your calculator? Not a bad idea, right? I can mess up that fraction.